Confused about how a brain might end up with a schizophrenia diagnosis? Curious about the subtle differences that show up super early and where they come from? Today, I'm talking about the developing brain in schizophrenia. Hi, it's Brain Bites with me, Dr. B. I'm Jessica Beachkofsky, your friendly online psychiatrist. Let's dig in. Let's start with the big picture. Schizophrenia isn't something that just shows up out of nowhere. People who develop schizophrenia have changes in cognitive, social, motor, and neurobiological processes during development, which happen way before the first psychotic episode. And as the brain continues through development, the differences from typical brain changes are more and more apparent. For people who have schizophrenia, they've often shown subtle signs way before their first psychotic episode. Things like delayed motor milestones as an infant, impairments in verbal, social, and memory functions during childhood, and deficits in processing speed, working memory, and attention. These impairments in cognitive and psychosocial functioning actually increase throughout development in people who later develop psychosis. And these issues often stick around even after successfully treating the positive symptoms like delusions and hallucinations. These cognitive and social problems, the negative symptoms, contribute significantly to the chronic disability seen in people with schizophrenia. To understand what's different about a brain in schizophrenia, let's briefly talk about how normal brain development works. It's a super complex process where billions of cells proliferate, migrate, and differentiate. As an infant, there's an overproliferation of immature synapses, which is how the brain sends and receives messages. So there are way more than you'll actually end up with. Then the brain uses environmental inputs to refine these connections into the efficient neural circuits we need. The process involves synaptic pruning of about half of these initial synapses and strengthening of the ones that are left. There are spines on the dendrites of the neurons. This is where most of the synapses are. These spines go through a process of either enlargement or destruction based on the needs of the brain. It's got to get rid of connections that don't help so it can put more energy into the important, useful ones. The pruning process aligns with decreases in gray matter volume and thinning of the cortex. Improvements in myelination and protective scaffolding around the neurons the brain wants to keep greatly increases signal transmission in the neural circuits. The primary sensory and motor functions are pruned in infancy, and higher cognitive functions are pruned during childhood and adolescence. Our brains are most flexible or plastic when we're young. These are critical periods where our brains are especially sensitive to environmental input. And as we mature, this plasticity decreases. There's something called perineuronal nets, which help close those critical periods of increased developmental plasticity. We don't want the brain to stay too plastic because we need stability for the existing synapses and circuits. Quick changes all the time would be detrimental to what's already working well. We know that schizophrenia isn't caused by a single gene, but comes from changes in hundreds or even thousands of genes that can increase risk. Many of these genes are involved in synaptic signaling and plasticity. Some genetic variations affect glutamatergic signaling and plasticity, neurotransmitter release, neuronal excitability, dendritic development, tagging synapses for destruction. And this relates to the theory of excessive pruning. But it's not all about genes. There's the whole nature-nurture thing too. Environmental factors are also super important. These include adverse childhood experiences, cannabis use in the teen years, poverty, low social support, and I'm sure there are many, many more. These factors combine with genetic risk, disrupting synaptic signaling and pruning during development. When we're stressed, our bodies release cortisol. Normally, cortisol helps us deal with stress, but too much of it can be terrible for our brains, especially during development. Excessive cortisol can lead to decreased survival of those newly formed dendritic spines, excessive pruning of the existing spines, and altered expression of a variety of genes. And this matters so much during development because of the increased plasticity and immature synapses and circuits. By the time the first psychotic episode happens, people often show reduced gray matter volume and cortical thinning across many brain regions, alterations in neural activation and connectivity between disturbed brain regions, and deficits in verbal memory, processing speed, and executive functioning. These changes are particularly prominent in prefrontal and temporal cortical regions, the same regions most affected by reductions in dendritic spine density in schizophrenia. Understanding all of this opens up new possibilities for treatment. If we can identify these brain changes early enough, we might be able to intervene before the first psychotic episode. It also explains why the teen and young adult years are such critical periods. This is when a lot of these changes are happening, and it might be our best time frame to make a difference. In the case of schizophrenia, the earlier we can make a positive impact, the better. So although we've got some great data and theories, we're still farther away from effective treatments for schizophrenia than most of us would like. But this look at schizophrenia from a neurodevelopmental perspective can help explain why schizophrenia can affect so many aspects of a person's thinking and behavior. We're seeing a brain that has been developing differently from the very beginning. I hope your brain is full of synaptic goodness, no pruning required. Be sure to grab more tasty tidbits at brainbiteswithdrb.com. Enjoy!